Okay, so continuing with problem B. Here, the first thing that we have to do is factor the denominator. So the right-hand side fraction is nice. X minus 2, I don't have to factor that. But on the left-hand side, I do have some factoring to do. Because these problems take up so much room, I'm going to kind of move over here and do my factoring on the side. First step in factoring is to always take out the GCF. So I can take a 4 out of everything. When I do that, 4x squared divided by 4 leaves me with x squared. Minus 12x divided by 4 leaves me with minus 3x. Plus 8 divided by 4 leaves me with plus 2. And then we have to check to see if that trinomial can be factored further. So two things that multiply to x squared is x times x. And I'm looking for two numbers that multiply to 2 and add to negative 3. I can do this in my head. I can use some shortcuts because the trinomial that I'm factoring has an a value of 1. Just makes it a lot easier. I don't have to go through the entire process. So this is going to be a minus 2 and a minus 1 to get factored form. So when I have it fully factored, I'm just going to replace the denominator with the factored form. And I could call this the least common multiple of the denominator or the least common denominator, either one. They're both right. So I could write it again as a list if I wanted to, but I kind of already have it there. So I can save myself a little bit of room. So I have a 4. Good, got that. I need an x minus 2. And I need an x minus 1. In order to be able to add these fractions, I need a common denominator. So I check. On the left-hand side, what is my denominator missing? Nothing. I don't have to multiply by anything. Awesome. On the right-hand side, what am I missing? Well, I've got the x minus 2, but I need a 4, and I need an x minus 1. So I'm going to have to multiply by 4 and x minus 1. So now I can write this all over one fraction. My common denominator is 4 times x minus 2 times x minus 1. But I'm going to have to do some multiplication up here to be able to write this all together. So I've got the x squared plus 3. When I multiply by 1, that doesn't change anything. So I've got 4 times x, which is 4x. 4 times negative 1 is negative 4. So I go through and combine like terms. Am I going too fast? No head nods. Okay. So I go through and combine like terms. I've got the x squared. I have a 4x plus 3 minus 4 gives me a minus 1. The next step is to factor the top and see if anything reduces. This top is not factorable. There's nothing that multiplies to 1 and adds to 4. So then that's it. It saves me a couple of steps there. Questions before we look at restrictions on that problem? Yeah, Jack. How do I get the least common denominator? You were absent yesterday, weren't you? Yes. Did you watch the video that I posted for you? Darn. That's what we spent yesterday doing. So the least common denominator has to have every factor from every denominator. So when I write this in factored form, I'm looking for what do I have, and then afterwards, what am I missing? So in the denominator, I've got a 4 and an x minus 2 and an x minus 1 and an x minus 2. I need everything in my common denominator to be accounted for. So I need a 4, I need an x minus 2, I need an x minus 1. This has an x minus 2, but I've already accounted for it, so I'm good. So you can kind of think of it like making a list and making sure that I have everything in the shopping list. Hopefully it'll become a little more clear the more problems we do. But up here, we did entire exercises just on that part. Yes. Okay. I can only add and subtract fractions when I have a common denominator. So I'm looking for what am I missing from my common denominator. Once I've decided my common denominator is 4 times x minus 2 times x minus 1, I look at this denominator. I'm not missing any of it. I've already got it. Perfect. And then I look over here. I'm like, oh, well, I don't have everything in the denominator. So I'm missing the 4, which means I multiply by it. I'm missing the x minus 1. Whatever I do to the denominator, I have to do to the numerator to keep my fraction equivalent. Okay? Similar idea. If I were trying to combine fractions like 2/9 plus 1/3, what's my common denominator? Well, both of those go into 9. I already have 9 here, so I don't need anything more. But here I would need a 3, and here I would need a 3. So similar, but very simplified idea. Cool? All right, let's talk restrictions. Four is just a number. It does not create any restriction on x. 4 is just 4. Of course, 4 can't be 0. So I take a factor that does have an x. X minus 2 cannot be 0. Therefore, x cannot be 2. X minus 1 cannot be 0. Therefore, x cannot be 1. So I have only those 2 restrictions this time. These 2 examples are of addition. I have another addition here, but I think we're going to skip and go to subtraction. Almost all the concepts are the same with one added step. So I want to make sure that we have enough time to spend some energy there. So we're going to go to example 3, find the difference. All right, cool. So I have 1. I have 1 divided by 6x minus 1 divided by x squared. This doesn't exactly need to be factored. If you find value in it, you could like try to write out 6 times x and x times x if that's helpful. It may not be. So my least common denominator has to have every factor, right? So I have to have a 6. I have to have an x. But this one over here has an x and an x. I've got to have everything in this list. So I'm going to have another x. Then I check. Does my least common denominator have everything from the left-hand side denominator, 6 and x? Yes. Does it have everything from the other denominator, x and x? Yes. So I'm working to get the common denominator. I need 6x squared. So on the left-hand side, I need an x. Whatever I multiply by on the denominator, I have to do in the numerator. And on the right-hand side, I need a 6. Now I have 6x squared for both denominators, so I can write it all over one denominator. X times 1 is x, minus 1 times 6 is 6. See if there's anything that you can simplify. There's not. I know it can get tempting to try to cross things out, but I can only simplify if I can take it out of everything. So I cannot simplify these x's, all right, because I don't have an x with the 6. I cannot simplify these 6's because I don't have a 6 with the x. So there's nothing else here that I can simplify. That's it. This is a more simplified example. And then if I were to look at restrictions, what value can x not be? Again, if you like to write this out in factored form, you can. Not really necessary. But basically, x can't be 0. That's the only restriction. If I plug in 0, I get 0 squared, which is 0. 0 times 6 is 0. I can't divide by 0. I'm going to do B, and then maybe have you do a practice problem. So let's look at B. For those of you who really like to have steps for your problems, here's some rough steps. For this process. A lot of times we stop after step 4 because we may not be able to simplify. Sometimes we have to go all the way. Cool. So step 1, factor the denominators. You guys are going to be so good at factoring by the time you get to your next math class. So you're seeing in this chapter a lot of quadratics with an a value of 1 just because it's easier on us to factor. We don't really need to be adding any more steps to this process. So on the left-hand side, you're looking for two numbers that multiply to 16 and add to negative 6. In order to get a negative 6, I'll have to have a negative 8 and a positive 2. And on the right-hand side, I'm looking for two numbers that multiply to 8 and add to 6. Multiply to 8. So 4 and 2, and they'll both be positive. So step 1, factor denominator, check. Step 2, find the least common denominator. So I can use these as lists. I need to have everything from the first denominator and everything from the second denominator. So I need an x plus 2. I can check those off both lists. I need an x minus 8. And I need an x plus 4. So go back and check. Does this common denominator have everything from the first denominator? Yes. Everything from the second denominator? Yes. So that's step 2. Step 3, multiply by what's missing. Let's see, on the left, I've got plus 2 and minus 8. I'm missing x plus 4, so I'm going to multiply the top and the bottom by that. On the right-hand side, I'm missing x minus 8. I'm going to write this as one fraction because now I have common denominator, so I can write this over one fraction. And I have to combine the top. Here's where those math 1 skills come in. I've got x plus 4 times x plus 1. This is an expression and this is an expression. When I multiply that, it's going to be important that I include some parentheses here because I need to take those and distribute them. Ooh, I'm going to run out of room. Let's do this. Let's see. So I've got x plus 2 and x minus 8 and x plus 4. And you might want to use some scratch paper or the scratch side of your notebook to do that multiplication. So I've got the x plus 4 and x plus 1. You might end up using the box for that if you still like to use that tool. Or you might just be distributing. I'm going to scoot my notebook over and just do a little multiplication on the side over here. And multiply that all out. So x times x, x squared, x times 1 plus x plus 4x plus 4. So when I multiply that part out, I get x squared plus 5x plus 4. Now this problem is subtraction, so I have a subtraction sign, and then I'm going to multiply out the next binomial times binomial. I distribute again. X times x is x squared. X times negative 8 is negative 8x. 1 times x is x. 1 times negative 8 is negative 8. This lesson pulls in concepts from Math 1 and Math 2 and Math 3. Very robust. Before I keep going, are there questions I can answer right now? Nothing's been different so far from what I did with addition, but I'm about to add a step. Any questions right here? When I subtract a whole polynomial, I have to go through and I can change all the signs. Now, you can do this in one of two ways. You could rewrite this entire numerator without parentheses, which I guess we can do, right? Or you could kind of just go through and change the signs on your paper. So I'll show you both ways. The first parentheses don't change. But then I subtract x squared and I subtract negative 7x and I subtract negative 8. So those signs change. You could also just take your pen and go minus x squared plus 7x plus 8 and just kind of write over it. That would work too. So I combine like terms. X squared and x squared is 2x squared Oops, that's x squared minus x squared. Bless you. Those cancel. Different signs. 5x and 7x is 12x. Plus 4 plus 8 is plus 12. When you factor the top to see if there's anything I can cancel, I just take out a GCF. I get 12 times x plus 1. Nothing cancels. So we're just going to stop where we were and leave it. Ooh, cool trick. And leave it like this. Whew. So yes, adding, subtracting is a lot of work. The only difference with subtracting is that you have to remember to subtract everything on the top right-hand numerator and change all the signs. I'm going to pause this. Okay. So, oh, that's a typo. Hold on, there's a typo in here. What is a compound fraction?
Becca went through and got some Christmas stuff for the girls. This is all Harley size. There's another stuff that's not E size. So I just here you go. Okay. Thank you. There we go. Our girls are going to do style it after Christmas Day.
Beautiful. Appreciate it. Thanks, friend. We have daughters the same age. In fact, they were born the same day. So. Sharesies. Okay. Compound fraction. When you have a fractions in the numerator and or denominator in a fraction, it just means you have fractions in fractions. Yay, you love fractions, right? This is going to be great. Not so bad. So you want to pay attention to where the big division bar is, right? So I've got a large division bar here, and I want to kind of treat the top and then treat the bottom, and then I'll combine them back together. I want to rewrite this as one fraction. Well, 2 is not a fraction, so how can I combine these? I can rewrite 2 as a fraction by making it 2 over 1. And then my least common denominator here would be, let's say I have a 1 and I have an x, so just x. To get common denominators, I'm going to multiply the left-hand fraction by x over x. And on the right, I already have x, so I'm good. Now I can write this all over one fraction, and I have 2x minus 1. Then I'm going to do the denominator of the large fraction. X I can rewrite as x over 1 so that it looks like a fraction. And in order to add or subtract fractions, I need a common denominator. Again, my common denominator is just going to be 1x. Well, I already have x here. Perfect. Here I have 1. How do I get to x? Just multiply by it. So I multiply the bottom by x, and I multiply the top by x. Now I have a common denominator. I can write them all over x. And I'm left with x times x is x squared plus 2. So now I can rewrite this original fraction. So I have 2x minus 1 divided by x squared plus 2 over x. So I'll pause there before we move on to the next steps. Questions yet? Okay. I'm going to turn the big fraction bar into a division sign. Same meaning, different way to write it. I just changed my big fraction bar into a division sign. And I don't want to divide by a fraction. So instead, I'm going to multiply by the reciprocal. So the left side is going to stay the same. And I'm going to change this to multiplication. And then take the reciprocal of the right-hand fraction. Now I'm just multiplying fractions, which is what we did in 3-3. When multiplying fractions, we talked about how you can simplify up and down or diagonally. Well, conveniently for us, I have an x up top and an x on bottom. That can cancel. And that leaves me with a 2x minus 1 divided by x squared plus 2. And there's no factor on top or on bottom that I could take out of both. So I'm good. So I have a second example here just for more practice. So I've got the big division sign here, right? So I'm going to take the top, whatever I've got in the top, I want to combine that into one fraction, and then whatever I have on the bottom, I'm going to combine that into one fraction. My least common denominator here is I have an x and a y, so I need both of those. So what am I missing on the left-hand side? I need a y. On the right-hand side, I need an x. So I have a y minus 4x over xy. Same story on the denominator. In the denominator of the denominator, I've got an x and a y again, so my common denominator will be xy. So I can multiply the left by x over x and the right fraction by y over y. So make the top a fraction, make the bottom a fraction, and instead of that big division bar, I'm going to rewrite it with a division sign. We don't ever divide by a fraction. We multiply by the reciprocal instead. So I'll finish it up by multiplying by the reciprocal and then simplifying. The left-hand fraction stays. I change my division sign into a multiplication. And the right-hand fraction, we take the reciprocal of. Reduce up and down if possible, or diagonal if possible. Now I can't reduce up and down because I don't have an x and everything, or I don't have a y and everything. Same thing on this side. But I can reduce diagonally. These x's will cancel and the y's will cancel. And I'm left with just one simplified fraction of y minus 4x divided by x plus 3y. Okay, that is going to wrap up our 3-4 notes.